Here we go again. We got another series of videos we're going to release. This time it's going to be on low voltage components, low voltage shorts, how to identify those shorts. This series of videos is going to walk you from very basic to more complex systems, so you definitely want to stay tuned to that. And this video today we're going to cover air conditioning straight cool units working in conjunction with an air handler and electrical heating element that has low voltage issues that are shorting out and causing fuses to blow. We want you to leave this video more confident in understanding those key components and how to quickly separate one component from the other, and a step process that we're going to put up here that hopefully will get you in and out of that service call a lot faster. Stay tuned. We're at the smart board. We're going to have one perspective on this video. When we release our next videos, we'll have different perspectives. This is very basic. What I want you to do is just try to take something that's extremely complicated and just like everything I've said in the past, it's just a knot, right? You can if your shoe was tied and you had a knot in the lace and you can still take your shoe off. Just because you got the shoe off doesn't mean you took the shoe off and untied the knot and dealt with that as an issue, if that was an issue. It is an issue. You know, a lot of us, we want to hurry up and just kind of get through things, and we try to find a shortcut to that. And experience is really the only thing that's going to get you through something quickly, because you've been there and you've done it. And you've done it because you've worked out those problems. You've untied that knot. And so when you can untie the knot, you can simplify the problem. But if you look at the knot that I'm talking about, I'm going to go to this next screen here. This is what I'm talking about. And this is why I kind of use a shoelace as an analogy. If I wanted to look at these 5 pictures and say that every one of these had a low voltage short, we have a furnace, we have air conditioner outside, straight cool. We've got this image here and this image here. Looks like it's just an air handler. You can see the low voltage wire nuts. You got all these wires everywhere. Here you have a heat pump because we have a defrost control board, contactor, capacitor. We know that's an outdoor unit. This is an outdoor unit. 2 different outdoor units. But if we're trying to find out where a short is, and you got a bunch of cables everywhere and cable ties, and you're just looking at it from a very complex perspective, you're going to have a very frustrating time trying to get through that service call. And I know that low voltage shorts is probably one of the biggest complexities that we have as service technicians. And you don't even have to be a service technician to go through it. You could be on a maintenance and you could cause a short. A lot of maintenance guys cause shorts by removing capacitors, and they would pull these capacitors out. You know, the mount may have screws on this side over here close to the contactor coil, and you may just brush past it with something like your nut driver, and now you short it out because your contactor was pulling because it had 24 volts on it, and you just wound up shorting that to the cabinet, and you may be stuck on that maintenance for a couple of hours not knowing what's going on, and you're just replacing fuses. Or you may walk up to a call as a service technician and you may just replace the fuse on the transformer, or just replace the transformer if it doesn't have a fuse on it, and you may say, you know what, I fixed it. But the truth of the matter is you haven't really fixed the problem if the problem isn't understood, right? So if you take the problem and we just kind of, you know, look at the problem in a sense that there's a key component that's causing it. You know, here is a very clear, you know, several images here. I've got a transformer, a fuse. I've got the backside of a motor. This is the ECM module. I've got a sequencer. I've got a 9380 relay, a contactor, the thermostat, and I have a blower control board. And so if I'm dealing with a situation that is a short, and I'm looking at it from this perspective, you know, how is that going to change my next step? You know, especially if you don't have the experience already on what not to do. If you have the experience, then you're going to know what you should do and what you should not do, and you're going to shorten that distance. This is something that we acquire through time, trial, and basically you're just going to have to get through it. I want to take somebody that is either frustrated with this, not very savvy with it, interested in it, and someone who just wants to level up, and I want to leave you more confident, okay? And so how we're going to do this is we're going to, go over what these key components are for, why are they on the board, right? And what step processes that we need to take that I'm actually referring to. So let's just kind of go through them again. We have a blower control board. We have videos about this board that we go over a lot of low voltage stuff. We're not going to go through input and output voltages. We're just going to really cover just the bare basics on what is this board for. There to turn on the fan motor. Well, it has to have a G call. What is this thermostat for? Well, the thermostat is what brings everything on. And it brings it on in conjunction where air handler and condenser can run together. It also brings it on to where just the air handler can run by itself or just a heating element can run by itself. In a straight cool application, it's not going to run the condenser if it just needs to run for heat. And so we have two components in that air handler that are running. We have the heat strip and we have the blower motor. But those are high voltage components. We're dealing with low voltage short. So we're dealing with a low voltage component that controls that high voltage component. And so that's why we have a bunch of relays here. Contactor, 9380 relay. It could be, this relay can be replaced with several relays. I'm not going to run this relay in conjunction with this board, but I have them both here because in a straight cool application, maybe your air handler has a blower control board. Maybe your air handler doesn't have a blower control board, it has a blower relay. Maybe your air handler doesn't have either one of these two, but it has a X13 module. Well, these modules, they are 24 volts. There's a fuse here. This fuse is most likely blown, and that's why you're watching this video. If this fuse is blown, what should you do prior to putting that fuse in? And then if it blows again, what should you do next? Why should we not change out our transformer if fuses are blowing? If fuses are blowing, why would your transformer be the problem? Your transformer puts out 24 volts secondary voltage for controls. You're not going to have a bad transformer that's going to cause a fuse to blow. So if you have a fuse blowing, you don't need to change your transformer out because it's putting out 24 volts. And your fuse blowing, well, that's proof that it's putting out 24 volts or the fuse could not blow. And so we have to kind of step back, and even though in your application this is what you're looking at, let's look at this again. If we took this image and I had a low voltage issue, I know I'm dealing with a straight cool. The only low voltage component in that entire condenser is that contactor. Now, could I have a high pressure switch and a low pressure switch? I could, but that's 24 volts in, and as long as the switch is in the closed position, it's 24 volts out. So how is that going to short? Maybe if the wire is rubbing on a cabinet somewhere, sure. But I'm not going to go taking all these wires apart and say that, you know what, I'm going to strip this thing down and pull every wire off and cut all my zip ties and start looking for a nick. All right, that's the wrong way to go about this. We don't want to start looking for nicks and cuts and things like that. Should we eventually do that? Yes, we should, but only after we have identified that all these components are working perfectly fine. And the majority of the time that you have a low voltage short, if it's not in the thermostat wire itself, okay, it's going to be one of these relays, okay? Very common. And so we have to go back to that because that is where the experience starts to talk. the thermostat. You have to understand your path of electricity. On the low voltage side, this thermostat is fed 24 volts from the transformer. Now, I do not have a float switch on this board. We can assume that yes, a float switch is in the circuit somewhere. We could assume that the float switch is not a problem. Why would we assume that it's not a problem? Well, we wouldn't assume that that float switch is a problem any more than all of these wires, right? Because a float switch, all it does is it takes 24 volts in, and as long as the switch is in the closed position, it takes 24 volts out. So what we're referring to as components that you should be looking for is loads. Your loads. What are your loads? And a load is going to have 24 volts going to it and a common wire going back to the transformer. So relays are loads. A thermostat is a load. Circuit boards are loads. Fan modules are loads. The transformer is a high voltage load. Okay, it's not a low voltage load. What I mean by a load is when it's running, okay, there can be a current that is measured, and we can measure that with a meter. In today's video, we're not going to talk about how to use this meter here, although I have it up here to keep it in your mind. That is the main tool that you will use in diagnosing a short. When we get into heat pumps and then later on into zone boards and dual transformer, single transformer applications, we're going to have to use that meter. And I'm going to have to show you in other perspectives with loads that actually have shorted out coils on them and what amp draws we should be looking for. This fuse here that I have up on the board says a 5 on it. That means it can hold up to 5 amps. That's not 0.05 or 0.005. That is 5 as a whole number. So that means 1 amp, 2 amp, 3 amp, 4 amps, 5 amps. Now think about that for a second. Your condenser fan motor doesn't even pull 5 amps. Okay? Some can, but most likely yours does not. Your blower motor may not even pull 5 amps. So if you're blowing a 5 amp fuse, it doesn't make a whole lot of sense to say, you know what, just a blown fuse, I'll put another one in there. It must have been a storm. Could it have been just an electrical glitch? Sure. That means it won't happen again, most likely. That is very few and far between. That means like if there was tomorrow 50,000 low voltage shorts on air conditioners across the nation, and everybody's working out the bugs, right? 50,000 would be probably what, 300,000 hours, right? But that we can probably reduce down to less than 50,000 hours. But that fuse right there will probably be replaced. Nobody will know why it was blown. There will be most likely some sort of excuse. And I call an excuse because there's not a reason behind it. There's not a fact behind it. And you have to look for your facts. You have to look for what caused this fuse to blow. And so if you're expecting to put another fuse in there and wait around and it not pop, and you just say, okay, let's call it a day, most likely you're going to be back out there again. It's called a callback. And they're very annoying, they're not popular, and nobody's going to really like it. If you're a homeowner or very inexperienced and you're replacing your own fuse, you may make the mistake of running out of the number 5 and you're grabbing a 7.5 or a 10 or something higher than that because your auto parts store sold a bunch of different sizes and you're thinking, well, it looks the same, has a different number, but it plugs in just fine. You know, maybe it's being plugged in here, right? And so, and let me go ahead and highlight that again. This is the fuse that I'm referring to. Right there. This 3 amp fuse. You may pull that out, put another fuse in there. It sits in the cartridge holder just fine, and you're thinking, hey, it's good to go. And guess what? It ran for a little bit. To my knowledge, I didn't see any problems, and it didn't blow. Well, what did blow is probably your transformer. Why did your transformer blow? Well, because the transformer was only rated for up to 5 amps. All right, so once that inline fuse, you've surpassed, that number of 3 or 5, then the next thing to blow would be the transformer. So you want to make sure that you're dealing with proper size fuses. Also, make sure that when you're stocking your truck, you have plenty of fuses on you. And like I said, when we get into the next video on heat pumps, and after that, we're going to take this to another level. That's a little bit busier, and we're talking about a lot more loads. Obviously, heat pumps have reversing valves, has defrost control boards, and whatnot. And you may be having dual transformers, and at the end of the day, that one transformer may be just going to a UV light, or one transformer may be feeding a UV light, which would be an additional load. And then we'll get into zone boards that have a lot more loads on them, where you're getting voltage drops. And with a voltage drop, you're going to have a higher amp draw. And so you're kind of setting yourself up if you have low voltage. Low voltage I'm referring to would be like if your contactors are pulling in and you check the voltage on the side of it and it's like 21 volts. You have a voltage drop. Something's going on there. And there could be resistance somewhere on one of your wires where it's just not a good connection that could be causing that. Or you could just have too many loads coming off of that transformer. You just need to step up those volt amps. And so this is a 40 VA, 40 volt amp transformer, which is very common. Doesn't matter, I can call that a 75. But typically you're going to find a 40 VA with a 5 amp fuse. Getting right into it, you have a thermostat, a condenser, and an air handler. The first thing you want to do is understand where these components found. So we're going to do a little matching game. We're going to say that the transformer is found inside the air handler. The fuse is found inside the air handler. Okay? And then we'll say the heater relay, the sequencer, is found inside the air handler. Then we'll say the blower relay is found inside the air handler. So if you look at this, now you're not going to run a blower relay with a module, but if I wanted to take that last step out, I can say that this blower control board is found inside this air handler. Okay? And that means we're not using this, and we're not using this. And I'm marking these green because your G call will control these. So I'm trying to keep everything very color-coded here. I can't use white, so I'm using purple for heat. Let's just say that I'm not using a blower control board, that my model air handler is using a blower relay. And because I'm using a blower relay, I have a PSC motor, so I don't have an ECM, so I don't have a module. Again, the only thing that's left is a contactor here, right? Obviously the thermostat's not in the air handler, it's by itself. It's its own piece of equipment. So equipment, equipment, and equipment. Okay? These components aren't equipment, right? These components are found in the air handler, right? So we're going to say that maybe you have a module. So if that's the case, we don't have a blower relay, we don't have a blower control board, but we have a blower module. Again, that is found inside the air handler. Okay, so what about this contactor here? Well, this contactor on a straight cool air conditioner, it's found inside the condenser. And so if I wanted to just say this is our scenario, we're not using this component, we're not using this component because our air handler is a newer model, it's using a blower module, then the transformer, the heater relay, the module, the fuse, all that will be found inside the air handler. The contactor will be found inside the condenser. And if you notice here, I have color-coded everything for you. Okay, this is just another way of looking at it. You want to understand where these components are found. Because once you find out how to isolate them, then you can quickly get through the diagnostic and shorten the length of time that you're there, because you can do what's called a process of elimination. So I have to know, okay, well, my air handler has a transformer. Well, if I have a fuse that's blowing, I know that's not an issue. Okay, so the only two issues that I could possibly have, besides the thermostat wire, okay, that's inside my air handler, wouldn't be the nest of wires. It would be the module or the heater relay. This is controlling the fan to come on. This is controlling the heat strips to run, both low voltage. So let's look at this a step further, and now we're going to include the thermostat. Now that we know where our components are found, our thermostat receives 24 volts. The thermostat is a load. So you have well, that's not working out. You have 24 volts coming in, and you have common. Okay. Now you could have batteries. If you have batteries, then you actually do not need the common. So we're going to leave just the R up there. Okay. So 24 volts from the transformer. Okay. So we'll say 24 volts oh man, 24 volts into the fuse, 24 volts leaving the fuse. Where does it go next? Well, probably a float switch. Out of that, where does it go? Well, it goes directly over here to the thermostat. Another way of drawing that would be it comes all the way over here to the thermostat. Now your thermostat is an extension of this 24 volts. The thermostat will put power out for every single one of these relays. That's all it's doing, is just putting power out to every one of these relays. So we have to look at that. And so I'm going to write it up here too. We have R, and then we have our image of our thermostat. Okay, so pick some more colors here. We're going to say green, and we'll say purple. So we have green, and we have W for heat, which I'm using purple. I'm going to write those same terminals over here. We have G, green, that's our fan call, and we have purple, or in your case it could be white or it could be black, but I'm not going to use black on my board or white on my board because white's not going to show up and black's going to confuse you, I believe. So we'll just use purple like I've done in my other videos. And you do see purple a lot in the W call. So R, G, and W. All right, so I'm missing only one other terminal, and that's going to be a Y terminal. And I'm not going to get to that just yet. The reason why is because if I want to know, do I have a short between G or W, okay, then I need to know where I would find that at. Well, G and W go directly to the air handler. So we're going to write this one more way. I'm going to take this fuse where I have 24 volts. Leaving and coming over here to this image. And I'm actually going to take it and I'm going to say that our transformer is in here now. And so we're going to come over here and we're going to say we want red, we want common, and we're going to say I have red and common because my transformer is sitting right here. So let's go ahead and draw the transformer. This is where it's located. Okay, my fuse, this is where it's located. And so now we have 24 volts there. All right, so 24 volts is going to leave. Path of electricity is going to go to the thermostat. So there's our arrow. The G call and the W call will come only to the air handler because you don't go to your condenser to tell the fan to run or go to your condenser to tell the heat strips to run, not in a straight cool application. So over here we're going to put G and we're going to put W. Pretty simple so far. And so it's going to get this call as an extension of R. And so what we're going to do is we're going to say R will power G, R will power W. So if I said I want a G call only, that's only going to bring my motor on. If I want to bring my heat strips on, I'm going to have a call for G plus I'm going to have a call for W. Well, both of those go to the air handler and that's it. So as long as I'm not shorting out in any of the wires and I'm not shorting out on my thermostat, there's not many other places to look. I have to start looking in my air handler and I have to pretty much stay in my air handler. And then the only components I have to worry about is, my blower component and my heating relay component. So it's already pretty simple. I'm going to go ahead and just erase a couple of steps. We want to go ahead and take away these red lines that I put in here. And we're going to go ahead and just use G, ground, I'm sorry, not ground, green. And we're going to say the G call, we're color coding things now to make things simple. Okay. Red to the thermostat as an extension, it's powering G to run my blower. It's powering W to run my heating relay to bring my heat strips on. Okay, and now we understand that path of electricity. If we wanted to have a cool call, okay, I'm going to erase this last step. Matter of fact, I'm going to take this one out here as well. I'm going to go ahead and put red back. Say we're going to get a G call. Okay, and now we're going to say we have a Y call. Okay, because we want to bring on the air conditioner. The air conditioner outside. So we're going to come back and through the thermostat, we're going to energize Y. And so if I said I need to bring on the AC, the blower has to run and the AC has to run. Now notice I don't have Y in here. Y comes over to my condenser. So all I have out here is common and Y. That's it. And so If red is toggling Y at the T-stat, then as long as everything's wired up, we will energize the Y at the condenser. Okay? There's nothing more to kind of go over other than just label our image over here a Y. This is straight cool, electric heat. Okay? Gas furnaces are very similar. The W call just goes to a gas valve. They're a little bit more involved on that because there's a lot of safety switches before that furnace will come on and operate, which we'll cover on another video. So now that we know where our path of electricity is going, let's take it a step further and let's go back to our components again. So what we're going to do is we're going to go ahead and erase and rewrite this. I'm going to leave this here. I'm going to come back over here and we're going to go color by color. And we're going to say the blower relay is the relay that is energizing our fan motor. We are not using the module. We are not using the blower control board. Our model air handler is very basic. Maybe it had a fan converter or something. You never know. And it's got just a blower relay. So I can just put a G right there. You need to start looking at this relay and identifying it. Okay, that's a G call. Let's pick another color. My contactor on a straight cool application, start looking at your contactor a little bit differently. Look at that contactor as that's a Y call. And that's all it is. Now let's look at this blower relay. And let's now look at that blower relay as a W. Not blower relay, heater relay. Excuse me. The heater relay as a W call. Okay? And so we have G, G, Y, Y, W, W. We're not using the module here again. We're not using the blower control board here. So now when we're talking about I have a low voltage short, we don't want to look at it this way. We want to start going, okay, on that condenser, that's a Y. Okay. On this piece of equipment here, okay, that is a G. Okay. On this here, this is a furnace, so this is going to be a G or a W, right? Because it can control just the blower to come on. It can control the blower with the gas valve to come on. Okay. But as we're starting to look at this, you know, we want to look at this and say, hey, this is pretty easy. Now this image here, by the way, this is a heat pump. So I'm not going to cover this image, but if I were to look at this, I would say, okay, this is a Y, this is an O. That's it. Why? Because it's got a contactor. O, it's got a reversing valve. It has an R and a C specifically for the defrost control board because it's a load. Cover that in the next video. Let's go back. Very simple. So if my fuse is blowing, I don't want to blame it on a bunch of wires that may be nicked. I don't want to blame it on float switches. I don't want to blame it on a transformer. Definitely don't want to do that. I don't want to say my fuse was just bad. Okay, I want to say, well, what mode was it running in when it popped, when the fuse popped? Was I getting a fan call only? Was I getting a cooling call where my contactor and fan were both running? Was I getting a heating call where my fan and my heating element was running? So I can have the fan call all by itself, the fan with the contactor for the outside unit, okay? Which means I have two possibilities to look for my short. But remember, not looking through all those wires, I'm only going right for the key component, right? Or was I running in heat mode where I was definitely running a blower control and a relay and a heater relay. So if I'm always going to run the fan with the compressor, the fan with the electric heater, or the fan by itself, then the very first step, I told you I was going to do this in a step process. The very first step, and we'll write these down, should be step one. Oops. Step one. If I go to my thermostat and I said I only want to run my fan in the on position, well, we know that the path of electricity comes back to my air handler, and we know that this blower relay is located inside this air handler. Okay, let me go ahead and see if that's okay. Now, by putting the fan in the on position and the system in off, the path of electricity will only send power from R to G, right? Basically, we'll be connected here. And I can go right there, right where I just replaced my fuse, go back to my thermostat, put my fan in the on position. Is everything okay? Blower runs. If the blower runs, then guess what? We just tested out the wire and we just tested out the relay. So you just eliminated two things right there. You eliminated the green wire and you eliminated the blower relay. Now we're going to stay on G for a second. And the reason why we're going to stay on G for a second, because let's just say you're not using a blower relay. So that means we're going to come back over here and we're going to put an X on this relay because you are not using it. And we're going to say maybe your model air handler is using a blower control board. Okay. So we're going to call this G. Okay, that's the only G that's as a component that's working because we don't have this model. We don't have the module model. With the module, everything's integrated into it. So that means the arrow will come from here over to here, which means we will find this blower control board inside the air handler. So if I'm sending power on G and the fan runs, and this is my model air handler with this blower component, then I can't say I have a bad blower control board, and I can't say that the wire is bad, or any of the wiring inside the air handler for that matter too, that's associated with leaving the transformer, going through the fuse, out of the fuse, into the float switch, out of the float switch, to the thermostat, back through the thermostat wire on G, to the blower relay. I can't say any of that's bad. You literally have just eliminated the G call. You have two more things to eliminate. Okay? But before we get to that, we're going to say, well, what if we weren't running this blower control board? What if our air handler was a much newer model? And what if we were running a X13 motor module? So we're going to go ahead and put an X here because that's not the model we're using. We're still on G because it depends on what model you have. We're going to put our G over here on this module. Well, we will find this module inside the air handler. If you look at the pattern, G is always going to associate with the air handler because it's an air handler. And we're dealing with blower, which handles air. Blower components. So we want to first start with G, because G will always run by itself, or it will run in conjunction with Y or W. So don't skip around, start with G. We're going to leave off on the module, and we're going to go to step 2, and we're going to go ahead and let's finish up the air handler. Let's go ahead and do W. Now, if it's July and it's hot, you're not obviously calling for heat, hopefully. So you may want to skip this step. But in the springtime, early in the morning, you could have been running the heat strips. By afternoon, you could have been running the air compressor or air conditioner. And, you know, you may not know when your unit failed. And because of that, when the technician gets out there, if he's not asking the right questions, and if you didn't know the answer anyways, he should definitely be checking the blower, the air conditioner, and the heating element. So we're not going to skip off on this. All right, so we're on purple here. We're going to say number 2. We're going to go right for the W call because let's go ahead and finish up our air handler. All right, so we're going to go ahead and put a W here. And that means that red will energize fan and red will energize W on the thermostat. And obviously that will energize our blower relay, which is found inside the air handler. Now remember, we're leaving the G call here because you got a fan call with it. We're going to go ahead and erase this over here, clean that up a little bit. All right, so we're now giving 24 volts from W, which is going to my air handler. If my fuse does not blow and my heat strips are running, then obviously my heater relay checks out. It's good to go. My wire also checks out. I know it's good to go. And remember, it took 24 volts from the power source to run through the fuse, all through the cabinet, energizing float switches, coming back, leaving the air handler, going to the thermostat, energizing G, energizing W, back through the wire. So you're alleviating a lot of potential problems by checking off, 1 and 2 already. I know I don't have a problem with wires. I don't have a problem with my thermostat so far. And apparently everything in my air handler is golden. There's absolutely no issues inside my air handler because my relays are fine and my wiring's fine. Okay, so what's next? There's only one other thing left that we haven't covered, and that's the contactor. The contactor, okay, will not run in conjunction on a straight cool with the heat strip. So we're going to have to back a few things out of here. We're going to go ahead and take the W arrow from the heating element, heating relay, and we're going to take W off of this. We don't even want to look at it. Go ahead and just delete it. We'll leave it over here on the image. So it's a reminder that these are your 4 terminals, right? 5 if you have a common, but we've already covered that you don't need that for the thermostat to have a display. So we have G still, and with a cooling call, we'll go ahead and put Y here. Y goes to the condenser. And so if we look at Y going to the condenser, okay, what component are we referring to? Well, we're referring to the contactor. So let's go ahead and draw our arrow here. The contactor is located inside the condenser, and it needs 24 volts to send high voltage across the terminals so we can energize the condenser fan motor and energize the compressor. Okay, and so sometimes these coils can be a problem and they can short out, and the only way we're going to know if that contactor is an issue is to go ahead and put the thermostat now in cool mode. So before we put it in the blower in the on position, then we put the blower, we let the blower in the on, we went from blower on to system heat to energize the W. We check these 2 off, and then now we're going to go and put the system into cool, which will only energize the Y and of course energize the G. So step 3 will be test out Y. If Y does not short out, then we know that our contactor is fine. The wire going out there is fine. Thermostat's fine. All that's good to go. And so it's a process of elimination. Now, if our fuse is blown, one of the things that I mentioned, okay, in this step your fuse is going to blow. So if I have a problem on the wire or the relay, you won't even get past step 1, right? If I have on the blower relay. If I have a problem with if I'm good here and I have a problem with my fuse, you know, staying closed and it shorts open on a call for W, then yeah, it's either this or it's in the wire. And we're going to cover that on the next step on how do I identify if it's relay or if it's wire. That's very easy. And so what we're going to do is we're not going to go ahead and start unhooking a bunch of wires. So let's go back to that image. Why would you want to go unhook a bunch of wires? That's not a good idea. But let's just say I wanted to test out my contactor. On the low voltage side of the contactor, I can unhook one wire. Just one. I can go to my blower relay and I can unhook one wire. I can literally unhook one wire on this. If you look at these other videos we actually have energized every single one of these components individually. Because all we've been dealing with is electricity so far, high voltage and low voltage. We haven't gotten so much into the mechanical part of it. We've been staying on just electricity. And so this module has 24 volts going to it. It has a common wire and it has 24 volts going to it. That 24 volts is obviously the G call. This heating relay, the sequencer, has common on one side, it has 24 volts on the other, right here and here. The 9380 relay, if that's your blower relay, it can be a 9340, it can be any relay we've used in any of these videos. There's 24 volts down here, okay? One is going to have a common on it, one's going to have the G call on it. You can just simply unplug it. And when you go right to the source and you just unplug the wire, okay, you're not unhooking a bunch of wires in your cabinet. It's real easy to check it out and put it back in. So let's go through that one more time. If I didn't get through one of these steps, say right there at step 1, as soon as I energize my fan motor, my fuse blows. Okay, well, we're either in the wire with an issue or we're at the relay with an issue, right? I can go right to that relay, okay, or module or board, and I can literally unplug the G call directly from it. Change out my fuse and literally try it again. Now, if I have the relay or that component unplugged, there's still voltage traveling through the wire. There's just not a load, right? And so if this wire is shorted somehow to the cabinet, or if it's shorted somehow to common or something like that nature that gives it a path back in the wrong direction, my fuse is gonna pop. In that scenario, you know, I would know I have a bad wire, that it's not the actual control, it's not the load, it's the wire. So it's either going to be wire or load. So you have to first get through which one of these is causing my fuse to pop. And you can do that by using your thermostat as a tool, not unhooking anything. And then once you find which one is causing it to pop, you can replace your fuse, and then you can say, okay, I want to disconnect my load. So let's say you got through step 1, it was fine. You're on step 2, and as soon as you energize it in heat mode, your fan runs, your W wire gets 24 volts on it, fuse pops. Okay, well, go to your heater relay and unplug one of your low voltage wires. Try it again. Place your fuse, try it again. Okay, if it does not blow, then you know your wire's fine. It's going to be your relay. Same way, if you get through step 1, you get through step 2, and you're on step 3. Okay, air handler checks out just fine. But every time I get a 24 volt call on Y, my fuse blows. Okay? Don't start unhooking a bunch of pressure switches and all that. Just go right to your contactor, unhook one wire off the side of your contactor. Doesn't matter if it's common. It doesn't matter if it's 24 volts. You're just disrupting the path of electricity. And as long as you disconnect one wire, one of your main wires that comes back to the air handler, okay, most likely your 24 volt wire is what you want to look for. If you can disconnect it right there at the load, then you have eliminated any pressure switches, any wires in that cabinet. You've eliminated all that. You just pulled it right off the source of the load that could be the problem, and you test it again. If your fuse does not pop, well, then you found your problem. It's at that component. If your fuse does pop and you have this disconnected, well, then guess what? It's somewhere in the circuitry. It's not the coil. So you want to take it a step back and you want to maybe unhook the low voltage wires going into the cabinet, okay, if you have pressure switches and whatnot, and see if it does it again. If it does it again, then it's obviously within the wire that comes from the condenser back to the inside. And you can just replace that wire. There's many conductors. There's very few thermostat wires, T-stat wires out there that have less than 8 conductors these days. I'm going to go ahead and come off screen just a second just to kind of show you what I'm talking about here. Here's a low voltage wire. And in this jacket, a weed eater can hit it outside as it comes out of the ground and goes into your condenser cabinet, and then it comes up into your cabinet, and you have all these conductors here, but really you're only using a couple. You're using yellow, most likely, and you're using blue for common. And so if you can just really narrow it down to, is it the contactor or is it the wire? If it's not your contactor, then it's in the wire. You can literally just take this wire out, pick another color, and make the change on the inside. It's very simple. Okay. Straight cool low voltage shorts, straight cool equipment with low voltage shorts is probably the most common system in the U.S. is a straight cool unit. At the end of the day, we have many different sources of heats. So, for air conditioning purposes, you're going to have basic components like a contactor in there. You're not going to really be more elaborate than that unless it's a heat pump. So we don't need to really cover much more on this video as far as components go. Just a simple 3-step process. It's a straight cool. Test the blower. Okay, it's good. Test the heating element, not the heating element, but the heat call. Okay, if it's good, okay, you have one left. Go to step 3, and now test your Y. Now the reason why I put this in this order is because if you take step 3 away and you look at just step 1 and step 2, every bit of that's in the air handler. If you look at step 3, every bit of that by itself is just in the condenser. Step 3 is only in the condenser, unless we have a problem with the wire itself. And the only time you can have a problem with this wire is if you take this common here. If this common has got a nick somewhere and this other wire had a nick in it and they're touching, you're going to have a short. And most likely that's all it is. But these contactors, they short out a lot. When we get in the next video, I'm going to show you how to test all this out using a meter so you don't have to go through fuses. How do you know how much amp draw you should be pulling with all these loads calling at the same time? When we get to a heat pump, we're going to have to add an O. Take the W out, we'll add an O. So, and in this application, you're either running G by itself, G and W together, or you're running G and Y together. So you're going to have a much lower amp draw because you have less low voltage components pulling current off of that 40 VA transformer. On a heat pump, you will have a higher amp draw because you are running more components. You have a defrost control board. You have a reversing valve coil, right? And we're not getting into low pressure switches and high pressure switches because those are not loads. A load will have a 24 volt wire going to it and a common leaving it. And so if you have 24 volts going to it and common leaving, that makes it a load, okay? Because without a common, you have absolutely nothing. And a lot of our shorts wind up coming back to a problem on the component, not necessarily the wire. And this, you just have to like take it like a shoelace that's tied real tight, and you're just, honestly, you're not taking the time and consideration to unravel that knot, because you're looking at it going, oh, that's going to take too long, it's too complicated, I don't have time for it. So you just kind of get through it by kicking your shoe off, right? Well, that's not good when you take an air conditioner and you say, I don't want to spend the time to mess with this thing. This thing looks too complicated. You know, I'll just, you know, have somebody else work on it who's more experienced, or I'll just call it something else that sounds more complicated, and I'll just kind of fake it until I make it. That's not what this industry needs. This industry needs people that are going to take their time, call in your office, say, hey, listen, I'm on a low voltage short. I'm probably going to be here for a few minutes. Just want to give you a heads up. That way your team at the office knows what's going on. If you're a customer and you're you know, frustrated that your technician is going back and forth all over your house, and he's telling you have a low voltage short, and he's saying, hey, just give me a break. You know, he needs a break. Give him a break. He's trying to unravel a complex knot that's in our industry that, you know, it's something that you want him to have the time and patience to get through. You don't want him to try to rush through that. Once he finds out what the problem is, fixing it's not going to take long. But when you get into low voltage shorts, those will be some of your longer diagnostics. This video is to help, you know, show that it can be done in a very simple, you know, 3-step manner. You know, again, step 1, run the blower. Okay, does that check off? Great. Step 2, run the heating element. Unless it's like July. Okay, if that checks off, great. Run the system in cool mode, all at the T-stat, because now we're running blower and the compressor contactor, and eventually with one of these 3, you're going to see which one is causing your fuse to blow. And then go right to the component, unplug one of the low voltage wires so you can stop the path of electricity and go back and do it again. If it doesn't blow, it's the component in that case. If it does blow and your component is unplugged, replace one of the wires. It's that simple. And when I say replace one of the wires, I'm not talking about the entire wire. If you have this many conductors, just pick another one. Well, what else do we need to cover? We have a lot to cover on low voltage shorts. This will be a lengthy series of videos that, you know, this is just a very basic foundation. So if you work on a lot of heat pumps, you know, I would still recommend, you know, share this videos with others, because it's a good foundation. It's a good start. When we get into the next video, we're going to step it up a level, and I'm going to expect you to be a little bit more understanding on heat pumps, so you can get through that video. But there's a rewind button. Rewind it as many times as you need to. Share the video with others. That's the way that you can continue to pass knowledge on, right? Share it with your team. Like our channel. We need that. That supports our algorithm so people can find us, because it's a liked video. Leave a comment. We read those comments. We've had a couple comments where people are wanting to get into low voltage stuff. So we picked this series of videos to try to get through. We know there's going to be a lot of low voltage issues. A lot of people out there cutting grass right now. A lot of weed eaters around those condensers. You know, a lot of your problems can be very simply found. Another thing too, if you see a low voltage wire coming out of the ground that's all beat up and it's frayed, and you see exposed wires, don't just electrical tape it. Cut it out, make a splice, and then make a good splice. You know, maybe sleeve it, the new wire, in a 1/2 inch or 3/4 inch seal tight. You know, just some Carflex. You know, so if they are back there, they have a lawn company that's a little abusive to sensitive stuff like this, it's better protected. Help your customers. Be the hero. They need it, and you need them. Subscribe to our channel if you haven't done so already. Hit the notification bell so you can be notified as we release these videos. We release videos weekly. And stay safe and stay tuned.